Hello, everybody just joining us. We were looking at the example that we ended with last time, and let's see if all the honors kids are ready to participate now. They did it once, then they got confused when I tried to have them do it again, and now we're doing it a third time. What does REF stand for, guys? Row echelon form. And what does it have as its key characteristics? One's down the, what did I call it just a second ago? Main diagonal. One's down the main diagonal. Zeros everywhere below the main diagonal. And I don't care if there are numbers on top, as long as I remember to do what to finish the problem. And so we came back here and we said, oh, back substitution is required if you get it into REF row echelon form. But then I was asking one more thing. Yesterday, if you guys watched the video, hopefully some of you made a deal that you would be taking this class in different class periods, and I said as long as you watch the videos, and I've heard recently a lot of you are not watching the videos, you are breaking our deal. I'm going to have you watch this one today, and hopefully you hear this announcement. But coming back, what are row operations? When did you guys first see them? What section? You saw them in 7.2, and now you are needing to use them yet again in 8.1. Because technically all along I was getting you ready for matrices whenever we called them row operations. We can get zeros by the system. The system says multiply the row with the established one by the same but opposite of whatever you're trying to eliminate, whatever you're trying to make zero, then add. The system says to get a 1, you multiply by the reciprocal of what you have that you're trying to get rid of. And the system says work by columns, going across rows but getting each column established first. So yesterday, what was the very first thing that I needed to have ready to go? And this entire system made into an augmented matrix, what was the first thing I needed to make sure I had if I was trying to work by columns and get the first column good? I needed a 1 in front, meaning at the very top. Does that make sense? A 1 in front of the first equation. And I already had it, so that was good. What did I need to do next? Get zeros. Look, I actually gave you the words to how to answer these questions. Get zeros. And so I got zeros by taking row 1 in both examples, multiplying row 1 by whatever was the opposite of negative 1, positive 1, opposite of 2, negative 2, by the opposite of whatever's there. And then I added to that row that I was trying to get the 0 in. Boom, boom, column 1 done. After I have column 1 done, what's my objective? What's my goal? Move on to column 2 and get the 1. Now, as I was looking at column 2, I need the 1 in the first spot, the y spot of the second equation. How do I get a 1? Over here, what's the system say? Multiply by the reciprocal of what you have. What did we have? What is 1 over negative 1? Aha! Now, it wasn't super obvious. It looks creative, but it really wasn't. It was actually following the system of multiplying by the reciprocal of negative 1 is 1 over negative 1 is negative 1. What's negative 1 times 0? Haha, it stays the same. As long as I follow my system, I will not mess up the earlier values. But negative 1 times every other term, remember, go across the rows, all the way across. Legal row operations, what I do to one term, I have to do to the whole equation. And I got my established 1. Once I got my established 1 in the second column, what was my job? To get? Now, did you notice that I said zeros yesterday? We actually ended up only getting how many in the second column? We only ended up getting a 0. Why? Because we were going to what form again? And row echelon only needs zeros. Where again? Under or below. Could I have gotten a 0 here? Absolutely. But would that be row echelon form? Not necessarily. Not necessarily. So I only went below, but there's this idea of maybe in other circumstances I will go above as well. We only went below. We went below by saying, what is there and what was there that I needed to get rid of? And how does the system tell me to get a 0? Multiply whatever row has the established 1, aka row 2 is where my 1 is, by the opposite of what I have, a negative 8. But remember, when I do that, I have to do it to every single term in the row. So 1 times negative 8 was negative 8 plus 8 made 0. Awesome. But negative 2 times negative 8 was 16 minus 10 was 6. Negative 2 times negative 8 is negative 16 minus 4. Wait, what? Negative 2 times negative 8 is positive 16 minus 4. Is that better? But how much math did I do yesterday, guys? How much mental math? And what's dangerous when you do mental math? If I'm doing it fast and if I'm not going carefully, can't I make mistakes? At the end of the day, I did get row echelon form. I was able to take that row echelon form and write it again as a system of equations using back substitution to get my final system. But what was the really cool thing I showed you in my calculator at the very, very, very end of class?
You just plug in the chart.
Plug in the chart. What's the actual name for it?
Augmented matrix.
The augmented matrix, otherwise known as the matrix itself. But yes, I plugged in the matrix. Did anybody follow what buttons I used? Maybe you should look at your TI graphing calculator and have it out today. We are going to learn how to do a little bit more by hand. However, it is only right that I teach you how to use your tool as well, because then you can also double check your work before you use up all your 4 answer submissions on WebAssign. Somebody tell me, where is the matrix menu? The red pill or the blue pill? What? X negative 1. Do you see it? Hit the second. Hit the X negative 1. There's a whole matrix name above it. And then, what happens if you just hit no? No. I want to put it in. Does anything up here say maybe I could put it in? Edit. Use your vocab. Knowledge. Oops. Edit. Edit what? I don't know. Just pick the first one. What am I supposed to put here? Well, guys, what goes up here? Oh. What does this do? Oh, it's the rows by column. So this is telling it what size to make it. So what size are we going to make this augmented matrix? 3 rows by 4 columns. It's a 3 by 3 coefficient matrix with an extra column for solutions. Now what do you have to do? Input. You guys inputting? What happens if I get to something like the bottom where there is no Y term? No as in none means skip it, but make it 0, right? Or make sure it is 0. Does that make sense? Oh, I lost my calculator. There he is. How are we doing? We putting in our very first matrix? A matrix that represents a really nasty 7.3, 3 equations for 3 unknowns. Any questions about how to get here or how to put it in? Ryan, go.
What was the buttons that you used to get to the matrix again?
Second, X negative 1, because there is the name of a menu matrix right above that button. Then I had to go over. I don't know, it was confusing after that. But after I get to second matrix, I'm going over to edit. Using my knowledge of what edit means, I'm hitting enter on whatever guy I want to hit enter on. I'm making it the proper size for the matrix that I need. And I'm putting in all of my numbers term by term. Hey guys, do you know where one of the most common places to make mistakes in these problems is? What you just did. Accidentally forgetting a negative, accidentally putting a term twice, accidentally typing the wrong number. Do you know some people have entire jobs of just putting in data? Be accurate. One little wrong number will mess up the whole thing. Are we all there? Are we all caught up? Are we just staring at a matrix that's already in our calculator? Is that good? Second mode. See them? There's the buttons. Second matrix. Go to the matrix. Second X negative 1. Second mode. Second X negative 1. Follow the buttons. They're right there. Second mode. Quit. Second matrix. Got it. I want to do some math. I want to do some math. You can scroll down. What does REF stand for? Somebody yesterday said, why doesn't theirs look like ours? Well, first of all, hold on. There's REF, row echelon form of who or what. Go back to the matrix menu and tell them which one you want. Use the name A. So I went to the matrix, second x negative 1. I went over to the math and down, 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 down until I found REF, hit enter, then I did second matrix, use the name A, and I can say go. Question. Are there ones down the main diagonal? Are there zeros below? Does it look the exact same as ours? So does that mean we're wrong? Well, but that's not getting the REF though, is it? No, that got you the final solution, which is really cool, and we talked about it yesterday, so I'm not trying to hide it from you, but what I am trying to say is, why is theirs different than ours? Why is theirs different than ours?
How'd you get
Second, x negative 1, over to the math menu. Go down, 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 until you find REF. And remember, there are people all around you doing the exact same thing. Hopefully they have their calculator and they can be used as a resource as well. The question is, this guy, is it the exact same as ours? The answer is no, because the numbers are different. But the question is, will it represent the exact same set of solutions? Guys, does z equal 2 on theirs?
Yes.
Yes. Does y minus 1.25 z equaling negative 0.5, does it get me 2 for y? How could we check? I'm not sure is a very wise response. However, how we could check is to go ahead and plug it in real fast, right? Because I could go ahead and plug in z is equal to 2 into the z spot. What's 2 times 1.25? What's 2 times $1.25? 250, right? And I'm going to add that to the other side. So what is 2.5 minus 0.5? Does it get me 2, yes or no? Yes. What do you think is going to happen when I come up here and when I say, hey, and this top equation is going to be x plus 0y minus 2z is equal to 3. If I plug in 2, I get x minus 4 is equal to 3, and if I add 4 to 3, I get 7. Question, is this a row echelon form? And the answer is yes. So what have you just seen about row echelon forms? This is one that gets you to 722. And this was one that got us to 722. What's true about row echelon forms? They are not, what's the word that says they're not by themselves and they can be written different ways? They are not what? Nobody knows this word?
Independent.
No. There are 2 different row echelon forms, which makes me think there might be a lot of different row echelon forms. If there are a lot of different ones, then one row echelon form is not what? Oh, you guys don't know the word. The mathematical term would be unique. Unique says it's alone. It is the only one. Are row echelon forms unique? No, they can be written different ways. Does that make sense? Now you might be like, well, how did they get theirs? I mean, technically, how did they get theirs? I think they probably rearranged their system just a little bit. And in rearranging their system, they still got to the same final result, but as they got to the final result, these are what we would call equivalent systems, meaning they mean the exact same thing, they're just written different ways. So for instance, I think they might have, let's see, that one ends up with a 0. I have to peek at it for a second. Because their second equation, the original second equation, is not the second equation that they used. No, that wouldn't have been it. That wouldn't have been it. I have to look in the programming to remember how they do their row echelon form. I rarely ever use it because some of you have already realized there is a much cooler button in the calculator, but let's at least be able to say from this page that REF forms are not unique. We can say REF forms are not unique. But what's that other really cool button on the calculator that some of you guys noticed because maybe you hit it the wrong way or maybe you remembered from yesterday there was a cooler one? How do I get there? Second matrix. Over to the math. Down. Below REF I have RREF. How do I put the matrix that I want? Second matrix name. Enter. What's so cool about this one? Is this unique?
What is REF?
Row echelon form is the REF. The RREF is reduced row echelon form. And gives me the answer. It has 1x equals 7, 1y equals 2, and 1z equals 2. You guys agree? So is it unique? Yes, as long as there is only how many solutions? Oh, that's not 3 solutions. That's not 2 solutions. Why is that 1 solution?
Oh yeah, because only 1 point.
It is 1 point. It is 1 3-dimensional ordered pair. It is 1 x with its y with its z. It will be unique as long as there are how many solutions again? 1. So is there a case where there could be more than 1?
Yes. It's not a.
If I have planes that are intersecting, planes intersect in possibly how many points? Multiple. If they are intersecting in what we call a... Oh, do you guys remember the visualization of it? It was back in section 7.3. Man, I don't really have space on here. I don't want to make it super messy. I will install a page and then I will delete a page. What is the one way that RREF will not be unique? Let me really quickly say RREF of matrix. Isn't it parenthesis and then bracket? Am I getting that right according to the calculator? Okay. Somebody did just ask a second ago, what does the additional R stand for? Who heard me? Reduced. Which means zeros above and below. If possible. Oh, stink. That just got more complicated. We ended up with a main diagonal of what? Zeros everywhere else in the coefficient matrix. And what, even though it doesn't show this, what's over here in the solution column? And what does that represent? The x, the y, the z, the 1 point where all of these planes, ooh, that just got exciting. All these planes intersected. But then I said, would this ever not be unique? The answer is yes, it will not be unique. Anybody remember a little guy called Z equals A? Sasha, shout out. I think she beat most of us to this last time we saw it in 7.3. If Z equals A, no. When do we use Z equals A? Remind me of the 2 different cases, the 2 different scenarios when we will use Z equals A. Infinitely many, and when do I have infinitely many? 0 equals 0, or something true equals something true, and that would be like in the last row, right? We are wanting Z equals, and the Z goes away. But there is an OR. Anybody remember the OR? There's only 2 equations, but 3 variables. Do you remember what we would call those systems? It started with a non. Non what?
Non-square.
Because, remember how I've been talking about the coefficient matrix being a 3 by 3 or a 2 by 2? 2 equations, 2 variables, 3 equations, 3 variables. If I have a square coefficient matrix, that means I have enough equations for enough unknowns, and so that's why Joey just reminded us that we call them non-square. If I don't have enough equations, then I pretend the last row is 0 equals 0, which means z equals a. Is there still a place for REF and RREF? Kinda. But things get a bit more complicated, and some of you were like, what does that look like? Well, remember the few different cases. I could have something like, oh, stink, this is going to get rough. I could have like a this guy intersecting with like a this guy. Intersecting with like a this guy. Question, where are all these guys intersecting if it's like fan blades? No. They're intersecting in one line. So if they're all at the same angle, in some senses, to each other, but just rotated like a fan blade, like multiple fan blades, those would be representative of when you would have a z equals a, there are infinitely many solutions. The other one would be something like, what if you had like one down on the ground, and then one that's like up and down. And then you had, where did that other one go? I'm doing a fan blade again, aren't I? Well, I could show you the none, but that's not very exciting because that's not what you guys were looking for. Is it possible that we have no solutions? Couldn't that be a none? Because green would intersect red and blue would intersect green, but red would not intersect blue. So that would be like a no solutions example. And don't we call those ones inconsistent because they don't have any solutions? This would be a consistent independent. Down here, as far as infinitely many. I have the picture in my head, but I just can't reproduce it. So, to help me out with that, let me go ahead and zoom over here real fast to this guy, 7.3. Jamboards, chapter 7, 7.3, where we first saw this. And all the little cool pictures of, ba-doop. There it is. What did I need? I had one down on the ground and one, oh, I needed to go perpendicular. That's what I was missing. Anyways, there would be our solution with 1 point, and that's kind of the case that we were just doing with the 722, right? Different ways of having none, different ways of having infinitely many, different ways of having one, but just a quick reminder of what you're doing when you solve. There we go. So it's messy and it's imprecise, but it's the idea. We can have infinitely many. We'll put this in big old parentheses real fast. We can have infinitely many. What's going to happen is my bottom row is zeros, either because I'm forced, I don't have enough, or because it naturally happens in my RREFing, in my row reduced echelon forming, aka my row operations is a better way of putting that. But if I do get one solution, it is unique and it is the single solution. It's either single or it's infinitely many or if it's none. And we should be able to find that as we progress through our problem. Here's a homework problem. Here's a web assign problem. Quick question. Can you figure it out if you have not yet already? Ready, set, collaborate. I will check the answers in 2 minutes. Where did I tell you to look? Sorry, insurance. Okay.
Why is the mic on?
Huh? Where did I tell you to look for a hint?
Your friends.
It isn't homework. No, well, yes, your friends. And I told you and your friends to look where in your notes. Ryan. Yeah, kind of. I think I specifically said go back to where we wrote about getting zeros and getting ones. What's the question asking?
7.2.
Identify the elementary row operations being performed to obtain the new row equivalent matrix. What has changed? The top. The bottom stayed the same, right? Okay, what changed in the top? A 0 was gotten. Didn't I give you a hint? Didn't I say talk about the ones or the zeros? Now, is this a good row echelon form step? No, it's awful. Why would you get a 0 before getting the 1? That's dumb. I'm not saying this is like going towards row echelon form. They didn't say it was going towards row echelon form. They just said a row operation was done. A 0 was gotten. From our notes. Oh, guys, did you write this down? It was actually really, really important, which is why I wrote it off to the side. I made a big deal about it. I said it again today. How do you get a 0? From the system. From the system. Multiply a row with an established 1 by the same but the opposite, then add. What? Like. How'd I get this 0? I looked at what was there. 2. I multiplied the row with the established 1, R1, by the opposite of 2, and I added to row 3. So what would be the row operation that's being done here? Don't worry about the words. We'll talk about it in a second, but what was the math? What was done from here to here? Where is there a 1 corresponding to that 0 that was gone? Row 2. It's not perfect. It's not row echelon form. It's not going to be quite so gorgeous, but it's close. What can I multiply row 2 by to get rid of that 5? Why, Natalie? What do you see?
It's like the root that you put for the 0. If you multiply it times.
To get it to be opposite. And the ironic part is you already have a negative, so you're not actually multiplying it by a negative 5. You already have a negative, so what are you multiplying it by? 5. And then I'm adding it to row 3. Will that work?
Yeah.
For those of you for whom the mental math is a little dicey, what we could do is we could go ahead and take all of row 2. Multiply all of row 2, which is 4, negative 1, negative 6, by 5, which will end up getting 20 minus 5 minus 30. We are taking 5 times row 2, so I took row 2, I multiplied it by 5, the 5 distributed to everything, and what am I adding it to?
What is row 3?
Oh, good question. What row should it be?
1.
Yeah. I think I just stole that from whatever that last one was that I was just writing down or looking at. So what's row 1? And the top is negative 2, 5, 1. If you're not a mental math kind of person, show the work. Do the 5 times the row 2. Rewrite the R1. Line them all up. Keep them all lined up. And then add. Guys, what's 20 minus 2? Whoa! Where are you? 20 minus 2. Why are your calculators out? Use your brains. Negative 5 plus 5.
0.
Negative 30 plus 1. Is that what they did? So where are the words that match what I did, what you did? And I know that it is not specifically in row echelon form. They're building to that, but it was a legal row operation to get a 0 based on what we had right below. We had to think elimination, and to think elimination, we had to multiply this guy. I guess I could multiply everything by 1/5 and then add, ew, gross. Take the smaller number. Hopefully it's a 1, and just multiply it by whatever will make that cancel. Dun, 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 dun. Did we make the match? P.S. Number 8 is really similar to it. So, there is this underlying system that is taking human creativity, but not in the way that we rethink what we're doing every single problem, but in a way that we try to establish a system that will work every time, that we can maybe tell a computer to do for us. RRF in your calculator. What is the system? The system says, I don't care what's in these spots. I could tell a computer to say, I don't know, think about this is A, this is B, this is C, this is... They might stop doing that because if the system gets too big, you can only go A through Z and then you'll be done. So it might be something like A11, A12, A13, because you can just keep doing that forever. A21, A22, A23, etc. You can do that forever. But anyway, long story short, I could say, take whatever is being given to you. How could I generally always get reduced row echelon form from anything? Step number one, I would go ahead and say, hey, if that's not a 1, actually don't even care if that's not a 1. I'm just going to go ahead and do 1 over A11 to row 1. What am I doing? I'm multiplying by the reciprocal. Hey guys, what's the reciprocal if this is 1? What's 1 over 1? Yay! But what if it's the reciprocal of like, I don't know, it's a negative 5. What's negative 5? Times negative 1 over 5. 1. So no matter what I have, if I multiply it by its reciprocal, I will always get a 1, and that's always what I need to start. So I would always get a 1 there, and then I would have A12 divided by A11, and I would have B divided by A11. No matter what I have, I would get my established 1. P.S. I'm too lazy to do the dot, dot, dots. I'm just doing a solid line. And we would say, sweet, so we've already done the first part. After we get a 1, what would be the next step to solving the system or having a computer or coding something to solve? Get a 0. Because of what I just did, regardless of any number that is in that spot, I just made an established 1. So what could I do to make a 0? Thinking about what we just saw. I could add to row 2. No, I don't want to multiply by the reciprocal. If I multiply by the reciprocal, I'll get a 1. I don't want a 1. What do I want? I want a 0, right? Yes. To get a 0, don't I need something to cancel?
Multiply by 1 by same opposite.
Multiply the row 1 by the same but by the opposite of whatever is in that spot. Whatever is in that spot, make it negative, make it opposite, multiply it by row 1 because there's definitely a 1 that's chilling there. And now all of a sudden, what am I going to get? Well, let me go ahead and actually write this down for the next one because that was my next operation, was negative A21 plus row, oh wait, no, times R1. My first one will remain exactly the same. A12 over A11, B over A11. I will indeed get negative A21 times 1 plus A21 is going to be a 0, which is exactly what I wanted. Now it's going to start to get a little messy in the sense of I am going to have negative A12 times A21 all over A11 plus A22. But guys, this is a formula that a computer could follow. It's like whatever that number is times whatever that number is divided by whatever that number is plus whatever that number is. Remember, your calculator does not freak out with decimals like its REF showed. I'd have something similar here in that I would be multiplying this guy, so it would be negative A, because I was writing this guy first, B times A21 all over A11 plus C. It's not gorgeous. But the computer, once again, the calculator is programmed like a computer. Has an operating system and everything. I'm getting it into reduced row echelon form. Then I could go ahead and say, hey, whatever that bottom is, I need an established 1. And to get an established 1, all I'm going to do is multiply by 1 over that nastiness, which I'm just going to put in big old parentheses, negative A12, A21, all over A11 plus A22. With parentheses, I could totally have it do that, no stress. This guy stays exactly the same. Whatever was right there has now just become 1. Whatever was right there has now just become 1. And I have my first solution. Because my first solution is going to be this nastiness of 1 over my negative A12, A21 all over A11 plus A22 all times negative B A21 over A11. Is it gorgeous? No. Is it an answer that will be gotten absolutely every single time, regardless of whatever numbers are given for a 2 by 3 matrix? Yes. What is happening behind the scenes whenever you put in some sort of, let's see, what size is this matrix?
3 by 4.
Nope, that was the old one. What size is this one? A 2 by 3. So if I was to go ahead and change this guy to a 2 by 3, when I say a 2, when I say a by 3, it says give me anything. Give it anything? Give me anything. Why? Because even if this is something gross like a 17, and this is something gross like a negative 3, and this is something gross like a 1.25, it's going to be a disgusting system, right? That could be a 5, this could be a negative 1, and this could be a, I don't know, 82. Is that going to be fun to solve for anybody? Probably not. There's a decimal, and there's nasty big numbers. I guess you could do elimination with that one, not too bad. But how on earth is the calculator when you tell it something like RREF? Sorry, math. And when you give it that 2 by 3, how is it solving it? Exactly. Because there's a formulaic way to solve for it, and it doesn't mind the math. It's a system. But wait a minute, it's not just getting the bottom number. What else is it getting? Everything, which means not just the bottom, but also the, I see you, Sasha, give me 1 second, but also the top. So what would it be doing to get the top as well? It'd be finishing to get the final 0. And to get the final 0, it's like I have this, let's just call this something like BCD, sure, why not? I have this. All it needs is to do one last row operation, and that one last row operation says, hey, take whatever is in row 2. I did not have enough room. Hold on, I can do this. Take whatever is in row 2, add it to row 1 to cancel out whatever is currently there, which is this nastiness. And all I need to do is multiply by the opposite of whatever that guy is. Multiplying 0 by anything and adding will still get the 1. Multiplying this guy by 1 and then adding will cancel that guy out. And then I'll also be able to, well, you know what? I made him a letter, so I'm going to go ahead and say negative A12 all over A11 times D plus B over A11. Look, I can be a computer too. Well, no, but I can talk to a computer and I can tell it what to do, and it will solve for me every single 2 by 3 that could ever be given to me. And that's a pretty cool tool. But not just a pretty cool tool, but also a pretty cool system that you could, once you learn a little bit of coding, have a computer do for you as well. We're going to go ahead and try to do this guy by hand. We're going to do this guy by hand using the system that I just said, but we're going to do it in a way that we don't have to think about how to program it as a computer, but instead just how to follow a system like we would have the computer do that works every single time. Are we doing substitution? No. Are we doing elimination? No. Are we trying to think like a computer? Yes. Why? Because maybe someday you can think like a programmer. Here we go. Ready, marks, get set. My very first instruction would be, write, ooh, this is a homework problem. This is maybe a few homework problems. Can you just write for me what's called the augmented matrix? Sasha, go. Yes, you may. Don't forget to sign out. Oh, someone left their pen. That is not the system, because that's going to go missing soon. Yeah, take yours back when you get this one off. In my backpack because someone stole the other one that was back there. Very sad. In my backpack where it's nice and safe. So once you finish using it, please bring it back to me. And let's watch those AirPods and let's take that hood off like I said about an hour ago. Someone help Andy out. Make sure he hears me take that hood off. So, what is the augmented matrix? What do you guys got? This was a homework problem. Just writing an augmented matrix. 1, 2, 7. Oh my goodness, that's a homework problem? That's all you have to do? Go team. Are we okay? Are we good? What? This is an easy homework problem. What's wrong? But what's really nice about this one? Could I multiply the top row by the reciprocal of 1? Yes, but what do I already have? Yeah, I could multiply it by its reciprocal, but question, what's the reciprocal of 1 going to be? 1, and 2 times 1 over 1, and 7 times 1 over 1, whatever, it stays the same. So we're going to save some time. The computer would have thought through that. I get to say, haha, there's a 1. So what do I do once I have a 1, guys? I get what? 0. How do I get a 0, though? Keep it, keep it, keep it. You established the row. Okay, so multiply the same number, which would be 2, but what kind of sign? The opposite sign. I'm multiplying it by what? Multiplying what by -2? Row 1, and then I'm adding. If you need to, off to the side right now, you should be going ahead and thinking through what is -2 times that row 1, which is 1, and then 2, and then 7. Getting that, and then adding that to row 1, no, row 2, which is 2, and then 1, and then 8. The question isn't how much work it takes. The question is how accurate can you be? But for the rest of you guys, maybe you're trying the mental math. Mental math like -2 times 1 is -2 plus 2 is 0. -2 times 2 is -4. -4 plus 1 is -3. -2 times 7 is -14. -14 plus 8 is -6. I make it look easy, but I make mistakes too. You guys see them all the time. I have you to double check me and say, wait, I just did that math and that is different. So what would be best for you? Will it be 0? Will it be -3? Will it be -6? The answer is yes, but how would you get there accurately? Yep, get the 1. Get the 1 in one spot. Get the 1 in the second row. Get the 1 by taking the reciprocal of the second row. So all I have to do is 1 over -3 times R2, which is exactly what we would have told the computer to do. Whatever is in that spot, do 1 over that and multiply it by everything. But the nice thing is if I follow my system working by columns, what's -1/3 times 0? 0. That gets to stay the same. It always will if you work by columns. What's -3 divided by -3? Got it. And what's -6 divided by -3? Yikes. And that wasn't even a lot of math. I could stop and I could use back substitution, but we are trying to solve. And if we are trying to solve, we are going to try to do R, R, E, F, which means a leading diagonal of 1s, 0s everywhere else. And guess what we're going to have over here and off to the side? Our solutions, if they exist. Which they are, because right now I have a y equals 2, so basically I know that I have my one solution and it's coming. Guys, how do I finish my system? I get my what? I already got my 1. I could back substitute, but if I want to go all the way, 0's below and above, go get your 0. Go get your 0 using the system of take the opposite of the number that's there, multiply it by the established row, add it to get it to cancel, and make sure you do the same thing all the way across. That stays the same, that stays the same, that stays the same. Boop, 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 boop. If you need to, do the math off to the side. If you think you can mental math it, Test yourself. You have 4 attempts on homework, 3 attempts, something like that. See if you're getting them right. But negative 2 times 0 is 0 plus 1. Everything should stay nice and established if you're working by columns following the system. Negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 2 is negative 4. Negative 4 plus 7 is 3. How can you double check that the solution to the system is 3, 2? Plug it in as a matrix to your calculator and use RREF, or go back to what I was literally teaching Algebra 1A today. And Algebra 1A was how to test solutions to systems. How do you test a solution to a system?
Plug it in.
Plug it in, plug it in. Is 3 plus 2 times 2, 3 plus 4, 7? Yes. Is 2 times 3, 6 plus 2, 8? Yes, it is. Dun, 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 dun. Now we can go back to the very beginning of notes where it said, hey, how do you solve a system? Substitution, that's one way. Elimination, that's another way. Row echelon form and back substitute stair-step system, that's another way. Intersections, that's another way. And now we can say matrices. Now we can say matrices. So what if we were to have more fun? Johnny, go ahead. Yes, you may. Make sure you take your pencil back to sign out. Leave your pencil back there in the nice little pink rope loop where the clipboard is signed on. Grab it, sign back in when you come back. So cool, kids. How fun would this one have been to solve, like section 7.3?
Absolutely.
First 2 to get rid of the x's, second 2 to get rid of the x's, third 2 to get rid of the x's. From those 3, the first 2 to get rid of the y's, second 2 to get rid of the y's, third 2 to get rid of the y's. From those 2, get rid of the y's. No, from those ones, what would you have? Get rid of the z's, get rid of the z's, and then you finally have a w, and then back substitute to get the z, back substitute to get the y, back substitute to get the x. Matrices. Yes, you have a way to double check it on your calculator. However, what does this say? Solve. And for some of you that are about to be little smart Alex, there you go. Boop. Ryan, go ahead and go with your question as everybody augments their matrix. Give me a matrix. Maybe get to a brand new page.
I was just going to say, when you were solving it, you try to get, you know where the main diagonal you were talking about with the ones, and then you were trying to get everything to 0? Is that what we're going to do here? Same thing.
Because using a matrix is referring to going all the way with the matrix, not going back to a system and then doing back substitution. So with the matrix means RREF, all the way, main diagonal 1, zeros elsewhere. What's the final solution? All right, you guys should be augmenting your matrix. As you're augmenting your matrix, I will as well. However, what are we allowed to do with our legal row operations that might be helpful before you even start augmenting? Ah, does anybody have something that they would rather be in the first spot?
I just wrote all of them.
You really got all of that down in that time? That's impressive.
No, Sasha, wait, because I just wrote all that.
Technically, that would be a correct augmented matrix, but then your first row operation might be something like, hey, interchange row 1 and row 2, or interchange row 4 and row 1. Who wants to put what where?
Row 2 at row 1, and then row 4 at row 2.
Row 2 at row 1.
And then,
So Ryan wants to get all of his nice and neat ones at the top. So you want that one first? What do you want second? The last one?
Why wouldn't you put the nicest one?
Well, because what do I need for my very first step?
Well, a 0, but it doesn't matter.
No, I don't want a 0 first. I don't want to go dividing by 3 because I don't want to deal with the fractions, right?
No, like, I was saying, like,
Oops.
never mind. It doesn't matter.
the row 3.
To be honest, I think I might want row 4 to be row 1.
That's what I'm saying.
Oh, I got you. Why, Natalie? Why would you rather have, like, if you're going to move them, why would you rather put that one up there?
I don't know, it just looks nicer.
It looks nicer because it has less maybe for you to worry about.
Yes.
No, it's up to you.
Yes.
But if I were you, I would maybe do the exact same thing that we all are doing so that way we can check all of our work. Nat, Natalie said it. I didn't disagree. Somebody's paper ripped. I'm going to go ahead and make that one first. I'm going to go ahead and make this one second. Because I'm going to have to be using that top one to get zeros. And the easier the numbers, maybe the easier my work. Whoa, why am I writing it? Guys, what are we supposed to be doing? To augment. What are we writing down?
The coefficients.
So I'm going to go ahead and move this to be row 1. I'm going to go ahead and move, no, keep that to be row 2. And then I'll make this to be row 3, that one to be row 4. So I have 1, 1, 1, 1, 6, 1, negative 1, 4, 2, 25, 3, 2, negative 1, 1, 0, and negative 2, 1, 2, negative 1, 2. What do you need to double check that you have right before you do anything else, whether it's in the calculator or by hand? Do you have all of your numbers correct? Don't worry. There's a method to my madness. It's Jamboard, and the Jamboard is not necessarily like the snazziest thing ever as far as copying and pasting. But if I do this, and 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 if I do that, and if I do that, and then if I do this, then if I do this, then if I do this, I have more room. Oh, computer, you're killing me today. Alright, you guys are already taking a break, so I'm going to go ahead and say you've already used up. I was going to give you a 5-minute break, now I'm giving you a 2-minute break because you already wasted some time. 2 minutes, stretch it out, shake it off. Okay. How would we go about this solution? Quick heads up, this is your ticket out the door. If you don't have this example written down, you get to stay in during nutrition until you have it written down. So everybody go ahead and make sure that you are not doing homework. Make sure that you are Joy and Paul and Baron, Jackson and Brendan. If you don't have this example in your notes, you don't get to leave my room today until you do. So make sure your notes are open. Make sure your section 8.1 is open. Make sure you are trying this 4x4 because we need to get a 4x4 in our notes. We went ahead and rearranged it already, so we did some of the work for you guys that were ignoring us, and we need to go ahead and get this system broken down. So to get this system broken down, question, do I need to do anything to establish my 1, the first step of every column? Do I need to do anything to establish my 1? No, but what do I need to do in order to get my zeros? Multiply row 1 by the opposite of whatever I need to get rid of. For row 2, multiply row 1 by the opposite of whatever I need to get rid of. For row 3, multiply row 1 by the opposite of whatever I need to get rid of for row 4. Is the system making sense? No? So, there was a 1. I multiply this guy by a negative 1. Then when I add, it will make 0. There is a 3. If I multiply this guy by negative 3 and I add, there will be 0. There is a negative 2. If I multiply that guy by 2 and I add, it will be 0. I am trying to get my zeros.
Okie dokie.
I'm going to be doing the mental math. Some of you guys would need to be having your scratch work off to the side to make it nice and neat and organized. Some of you, the organization, that's brutal. So I'm going to go ahead and multiply this by a negative 1 and add 1, that's 0. This by a negative 1 and then add negative 1. Negative 1 minus 1, that's negative 2. Multiply this guy by a negative 1. Negative 1 plus 2 is 1. Multiply this by a negative, that's negative 6 plus 25 is 19.
Wait, isn't there like a... Yeah, aren't you missing a 1? Yeah, aren't you? 1. Isn't there supposed to be like a 4th, Yeah.
Ooh, I'm missing a whole column. Thanks, guys.
4 by 5.
I was doing a 3x4 for a second. What I miss? 1, 1, 1, 1, and then the 6. So let's pick it up there. So I have a negative 1 plus 4. That's going to go ahead and be a 3. A negative 1 plus 2. Negative 1 plus 2 is going to be a 1. And a negative 6 plus 25 is going to be a 19. How are we doing? We look good?
Yes.
Awesome. I'm going to have a negative 3 plus 3 is 0. I'm going to have a negative 3 plus 2 is negative 1. I'm going to have a negative 3 minus 1 is negative 4. I'm going to have a negative 3. See why Natalie picking that one as her top row is probably a good call. Negative 3 plus 1 is negative 2. And then I have negative 18 plus 0 is negative 18. I have my 2 times 1 minus 2 is 0. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2 plus 2 is 4. 2 times 1 is 2 minus 1 is 1. 2 times 6 is 12. 12 plus 2 is 14. It's much safer if you guys are doing any of the math to double check my steps, similar to how your classmates saw I was missing entire column. But does anybody know why for the next step I'm going to go ahead and do a quick little like whoop whoop? Does that look like a smart idea?
Yes. So that you.
What do I need to do for my second column? I need to establish my... let's go back to section 7.2. Ryan Union, David Tan, let him focus. Ryan Union, is it a legal row operation to interchange rows? Yes, it is. He read it yesterday. It is a legal operation to interchange rows. So we can go ahead and do two things. Ready? I'm going to go ahead and interchange. Ready? Negative row 3 with row 2. Why do I want row 3 to be negative?
So that it could cancel out.
Sorry.
I want row 3 to be negative so that.
The 1. So the 1. Yeah.
This guy is staying the exact same because I'm not touching him. This guy is staying the exact same. Well, yeah, that works. But what's going to happen if I take row 3, if I make it the opposite, and if I put it in row 2, while putting row 2 in row 3, row 2 is going to come down here, and it's like, okay, it is what it is, right? But what's the opposite of this guy? Opposite of 0 is 0. Opposite of negative 1 is positive 1. Ha-ha! I just established him. Opposite of negative 4, positive 4. Opposite of negative 2, positive 2. Opposite of negative 18, positive 18. I established my 1. And once I establish my 1, what can I do for all my other rows? With an established 1, it is now time to get what? Starts with a Z and ends with a zero. It's time to get my zeros. So I'm going to keep that row 2. Why? Because it has my established 1. So I'm going to keep 0, 1, 4, 2, and 18. But I need to go ahead and get rid of all my other guys. Go ahead, Andy. What's up?
Oh, wait, never mind. You have to keep the 1 the same, right? In the top, or in the second row? Like in the same spot?
I'm interchanging these two, and I'm making row 3 be the opposite. So a positive, 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 opposite of 0 is still 0. And I moved that to the second row to get my 1.
Okay, yeah, and then you keep the 1, like...
I don't touch this row until I get my zeros. I got it. Go ahead. What's the question?
On the Jamboard, it's like overlapped on the part that you're writing on. So it's like hard to. Yeah. Like on my screen, like it's.
Is anybody else's screen not showing the Jamboard accurately? Maybe refresh your screen, Ryan, see if that helps. Because I did make a change.
Oh, that fixed it.
Okay, there you go.
Sorry.
No, you're okay. I understand. Coming back. I'm going to go ahead and get zeros. How do I get zeros? I look at what's there. A positive 1, a negative 2, a positive 3. And I say, let's take the opposite of that, a negative 1 times the row with the established 1. And then I'm adding. So negative, row 2 plus row 1. What's the opposite of negative 2? A positive 2, row 2 plus row 3. What's the opposite of a positive 3? A negative 3, row 2 plus row 4. Let's go. Negative 0 plus 1 is 1. Negative 1 plus 1 is 0. Negative 4 plus 1 is negative 3. Negative 2 plus 1 is negative 1. Negative 18 plus 6 is negative 12. Feel free to call out a math mistake if you see it. 2 times 0 plus 0 is 0. 2 times 1 is 2 minus 2 is 0. 2 times 4 is 8 plus 3 is 11. 2 times 2 is 4 plus 1 is 5. 2 times 18 is 36. 36 plus 19 46, 55. Ooh, someone better double check that math.
Oh, it's so good.
Negative 3 times 0 plus 0 is 0. Negative 3 times 1 plus 3 is 0. Negative 3 times 4 is negative 12 plus 4 is negative 8. Negative 3 times 2 is negative 6 plus 1 is negative 5. And negative 3 times 18 is negative 54 plus 14 is, I believe, negative 40. Once again, feel free to double check that math. I take those terms, the 1, the negative 2, the 3, that I need to get rid of in the second column. I multiply that row with the established 1 by the opposite number all the way across, and I add to whatever row I'm trying to get my 0 to eliminate. But what I do to one term, I must do to everything, which is why I'm doing lots and lots and lots of math. I'm double checking stuff with the 18 just to make sure. Negative 18 plus 6 is negative 12. 20, 36, 36 plus 19, 46, 46 and a 9 is 55. That works out, I believe. And negative 54 plus 14 is, I believe, negative 40. Anybody finding math errors?
I just have a question.
Uh-huh.
So why does it switch from like row 1 plus row 2 like to row 2 plus row 1?
Because I am following the system of getting my zeros, and getting my zeros says multiply whatever row has the established 1, which at the first one was row 1. And the next one is going to be row 2. And the next one, if I was to do it, would be row 3. But this was row echelon. I only did the bottom. I didn't do the top half. Now I'm doing the whole shebang to get RREF. But I use whatever row has my established 1, which this one was row 2. The first one was row 1. The next one is about to be row 3, except, row 3, I need to make a 1 first. I have a 1, I have a 1, I need a 1. What was the system for getting a 1 if I don't have it? Not row 2. I'm in row 3 now, aren't I?
Yes.
1/11th, are you kidding us? And I say no. 1/11th of 0 is 0, awesome. 1/11th of 0 is 0, awesome. 1/11th of 11 is 1, awesome. 1/11th of 5, not so awesome. 1/11th of 55, not too bad. Everything else stays the same.
Why for the last thing, why didn't you just take the 1116?
What?
Why did you add negative R?
Because I needed to get the 0, because I'm trying to get RREF, because only in RREF will I truly have the final solution at the very end. So I'm going not only below, but also above. You were thinking of REF. Now I want to get zeros for everything and everyone, and to get zeros for everything and everyone. Hey, Jackson, here's a good time for you to make sure you understand it. I'm taking the opposite of that guy, and I'm multiplying it by what row? Was row 2. For the third column, which one has the established 1? Exactly. I need to get rid of the 3. I need to get rid of the positive 4. I need to get rid of the negative 8.
Wait, but doesn't row 1 and row 2 already have an established 1 then?
But not for column 3. We work by columns. You guys fell a little bit behind as you were trying to do homework instead. I'm keeping that row 3. I have 0, I have 0, I have 1, I have 5/11ths, and I have 5. Gonna get to be a party with the fractions. As I multiply, whoo! 3 times 0 is 0 plus 1 is, oh, that's nice. 3 times 0 is 0, 0 plus 0 is, oh, that's nice. 3 times 1 is 3, 3 minus 3 is, oh, that's nice. 3 times 5/11ths is 15/11ths, 15/11ths times Let's go again. 3 times 5 11ths is 15 11ths. 15 11ths minus 11 11ths is 4 11ths. 3 times 5 is 15. 15 minus 12 is 3. Whew. It's kind of nasty, but we made it. I think I'm going to need to get 11ths for everything. This is going to be thought of as 22 11ths. This is going to be thought of as 55 11ths. Okay, negative 4. Whew. Negative 4 times 0 is 0. 0 plus 0 is 0. Negative 4 times 0 is 0. 0 plus 1 is 1. Negative 4 times 1 is negative 4. Negative 4 plus 4 is 0. Negative 4 times 5 11ths is negative 20 11ths. Negative 20 11ths plus 22 11ths is 2 11ths. Negative 4 times 5 is negative 20. Negative 20 plus 18 is negative 2. It's time for the numerical geniuses to shine. I am not one of them, so make sure you're doing them with me and check my math. We like the zeros. 8 times 0 is 0, 0 plus 0 is 0. 8 times 0 is 0, 0 plus 0 is 0. 8 times 1 is 8. 8 minus 8 is 0. 8 times 5 11ths is 40 11ths. 40 11ths minus 55 11ths is negative 15 11ths. I better double check that. 8 times 5 is 40. 40 minus 40 is 0. Oh, look at 0.
How many more are you the right numbers to get
I don't have any more room.
Oh, I just made everything 11 11ths, 11 11ths, 11 11ths to make it negative 11 11ths, 22 11ths, and negative 55 11ths.
You can do that? I've got that.
It's called getting a common denominator.
And you don't have to multiply like the other.
No, because I'm not changing the value, I'm just changing what it looks like. If I multiply by 1, it stays the same. Does that make sense?
Yes.
Yeah, I'm not changing the value, I'm just getting common denominators to be able to combine it with that dude. Baron, what do you see? Is there a mistake?
Why the negative?
Hey guys, show respect.
Why,
Take a breath. Show respect. Baron, go ahead.
why negative 5 times 11?
Good question.
11 is 15 divided by 11.
Because that's negative 55 11ths, so that I can combine it with 40 11ths, because 8 times 5 11ths is 40 11ths. Minus 5, my head gets fuzzy, but 40 11ths minus 55 11ths, I can do negative 15 11ths. I'm getting common denominators. Does that make sense? Just to make it easier on my brain. So 40 11ths minus 55 11ths, negative 15 11ths. I think, anybody actually do the math and say I'm good? Thanks, Paul. What is my final column step to do? My final column, how do I get this set up and ready to go? I get the 1, and I get the 1 by multiplying by the reciprocal. And reciprocal would be, yes, you're right, negative 11 over 15 times R4. But kiddos, what's going to happen when I multiply anything by 0? 0 by 0, 0 by 0, 0 by its reciprocal, positive 1 by 0, it's 0. Oh, that wasn't too bad. Whew, I got my established 1. And as I got my established 1, guess what? All I need to do is get what for the rest of the guys? Once I have the 1, what am I doing?
0.
I'm getting all my zeros. I am 1 step away. Well, 1 step that has 3 steps, kind of, right? I have my 3. I have my negative 2, I have my 5, I have my 1 and my 0, 0, I have my 0, 1, 0, I have my 0, 0, 1. I am so close to being done. All I have to do is say I'm going to get rid of that 4 11ths. Jackson, what row am I multiplying by? Where's my established 1? Good. Do you see it? You got it, bud. Good job. Negative 2 11ths. Let's get rid of it. Oh, wait a minute. I'm supposed to be adding this.
Wait, is it?
Negative 4 11ths, row 4 plus row 1, right? Negative 2 11ths, row 4 plus row 2. Negative 5 11ths. It's about to get a lot better. Hold on, those of you that are complaining, it's about to get a lot better. Why? Well, you'll see in just about 5, 4, 3, 2, 1. Question. What's anything times 0? 0 plus 0, got it. What's anything times 0? 0. 0 plus 0, got it. What's anything times 0? 0. 0 plus 1, got it. What's anything times 1? Well, okay. Negative 5 11ths plus 5 11ths is 0, but hold on. What's going to happen when I get to the last term? This times 0 is 0 plus 5. Oh, it stays the same. I'm not even worried because it just gets multiplied by a 0. So guess what's going to happen when I get to this? No. The 1 was supposed to go there.
She was sounding.
It's just going to be -2, and this one's just going to be 3. Has anyone double checked to see if 3, -2, 5, 0 is the solution?
Oh my god, Sasha, I said 5.
We were not looking at it.
How do we double check? Well, I guess you go back to the very beginning and plug in the x, the y, the z, the w to all 4 equations. Or how could you double check besides WebAssign? You could get here and you could say, I need to make myself a big Mama Bahama matrix, one that is specifically a 4 by 5. Isn't it huge? I think it's huge. I need a 4 by 5. That was a Mrs. Leon thing. The Big Mama was the huge review at the end of every chapter. I know, you guys don't know who she is. There's a 1, there's a 1, there's a 1. Her pretzels are kind of good. Now we know who she is.
Oh my gosh, she hyped those up so much.
1,
Oh, that's terrible.
-1. Oh, that's already good. 4, 2, 25. After this, if you guys are wondering, I am going to go ahead and go to number, what is it guys, 14? And look at number 14, since all of us seem to be having some major issues on number 14. Oh, I missed one. -1, that would have been dangerous. 4, 2, 2, 5. 3, 2, -1, 1, 0, -2, 1, 2, -1, 2. What should all of us always double check before using our calculator to solve? That we have put it in correctly. Now I can go ahead and see if I'm right. And I'm going to see if I'm right. If I go second matrix over to math up to the RRREF. Just kidding, only 2 R's. There he is. And I'm doing it to matrix A. And I'm saying, hey, sir, what is your solution? Hot dog. 3, 2, -5, 0. So for those of you guys that are trying to figure out what to do on something like number 14, instead of me picking another random example, let me go get number 14 for all of us to see. Sasha already wrote down what she had as far as the first part. Oh, look, 22/3. That is a solution. The question is, can you make it match? Can you get it to actually be a solution? Let's go ahead and get this. We had a few people right before we tackled this 4 by 5. We tackled the 4 by 5 because if you can do that, you can do anything. Well, almost. I wonder if z equals a is going to be a thing. We'll see in homework questions next time. But for right now, number 14, your classmates have gotten stuck. Your classmates have gotten stuck. So let's go ahead and see what's so rough about this one. I have 1, I have 2, -2, and -31. I have 0 and 4 and 2 and 0. I have -1 and 1 and -1 and -2. My classmates. I'm just kidding. My students. If you want help, shh. What does the rain do? Well, that didn't help. Okay, anyway. First step is get the established one. You have the established one. After you have the established one, what are we supposed to be getting? Getting the zeros. And so the opposite of -1 is a positive one. Positive 1, row 1, plus row 3. We should all be going in the exact same systematic procedure where I keep the first row and the second row. However, the third row, we should have gotten that 0, which I think everybody who was asking me this question, you did get. 1 minus 1 is 0. 2, technically I'm adding. 2 plus 1 is 3. -2 plus -1 is -3. -31 plus -2 is -33. Then after that step, I think Sasha write this on the backboard, and this is hopefully what you guys got. Double checking. It looks to be the same, except I forgot to write my 31. The next step they should have done. I'm moving on to column 2. Guys, how do I move on to column 2? What's the first thing that I should do? get the established 1. The established 1 would be multiplying by the reciprocal, row 2, unless you want to move row 3 and then multiply by the reciprocal of row 3. That might be actually kind of gorgeous, but that's all right. We'll go with what they did, and they kept this 1 in the second spot. So divide by 4, 0 divided by 4 is just itself. 4 divided by 4 is 0 divided by 4 is 0. 4 divided by 4 is 1. 2 divided by 4 is 1 half. 0 divided by 4 is 0. But everything else was supposed to stay the same, which means the 1 and the 2 and the negative 2 and the negative 31. Oh, I'm doing it differently. Oh, okay, whatever. And then my 0 and my 3 and my negative 3 and my negative 33. All right, cool kids. After I get my established 1, what am I supposed to do? Find the zeros. Have you gotten the system by doing the nasty one? Look at the 2. Multiply it by the opposite. Keep the row 2. Add it to the row 1. 3. Multiply row 2 by the opposite and add it to row 3. I am keeping row 2 the same because that's where my established 1 is. 0, 1, and then 1 half, and then 0. I'm seeing what happens when I do the rest. So what do I have? Negative 2 times 0 plus 1. Negative 2 times 1 plus 2. Negative 2 times a half is negative 1. Negative 1 minus 2 is negative 3. Negative 2 times 0 minus 31 is just negative 31. Negative 3 times 0 plus 0 is 0. Negative 3 times 1 minus 3 is 0. Negative 3 times 1 half is negative 3 halves. Negative 3 halves minus 6 halves is negative 9 halves. Should probably double check that. Negative 3 times half, negative 3 halves. Negative 3 halves minus 6 halves is negative 9 halves. Negative 3 and 0, and that is negative 33. People who are doing this problem, same so far?
Yes.
If so, then we should get down to that final column. And that final column, we should be getting a 1 in the final row. And to get a 1 in the final row, we are multiplying by the reciprocal of whatever is there. Any number times 0 is 0. Any number times 0 is 0. Any number times its reciprocal is 1. Any number times 9 and 33 can reduce to 3 and 11. 3 and 11 times 2 would be 22 thirds. Keeping everything else the same, I would have 0 and then 1 and then 1 half and then 0. I would have 1 and then 0 and then negative 3 and then negative 31. Then I would get my zeros, and to get my zeros I would need to do 3, R3 plus R1, and negative 1 half R3 plus R2. Let's see, is WebAssign right or are they right? I have 0, I have 0, I have 1, I have 22 thirds. I already know that's right. Let's get the rest of them. Negative 1 half times 0 plus 0, well that's easy. Negative 1 half times 0 plus 1, well that's easy. Negative 1 half plus 1 half, that's easy. Whew. Negative 1 half times 22 thirds, the 2 and the 22 reduce to be negative 11 thirds, plus 0 is negative 11 thirds. As I come up here at the top, 3 times 0 plus 1, that's easy. 3 times 0 plus 0, that's easy. 3 times 1 minus 3, got it. Okay, 3 times 22 thirds, the 3's reduced, 22, 22 minus 31 ends up being negative 9? Double checking, 3 times 22 thirds is 22, 22 minus, I believe it's negative 9. Let's check it, negative 9, negative 11 thirds, 22 thirds. I think, dun 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 dun.
Oh, dang, I can't see.
Oh yeah.
This isn't working. The amount of times you multiply and add is baffling.
Didn't you guys miss numbers? They're back.
No.
I missed regular numbers, not these numbers.
You did that at least 7 times.
More than that, for sure. Hey, cool kids, you have about 35 seconds left in class. Go ahead and take a nice deep breath. If you ever try to do RREF in your calculator and it does not get you to what we call an identity matrix, oh, you'll want to hear this. You'll want to hear this. If you do RREF in your calculator, some of you guys are like, that's all I need. Ha, homework done. Who cares about the work? I'll miss the 1 point. If your calculator ever gets you not all the way, it means it's a z equals a. If your calculator cannot get you to a leading diagonal of 1, zeros below and zeros above, it's a z equals a. Maybe bring those homework questions on Thursday. Bye, guys.
Actually,
You do your back substitution, right? You always do. That one the calculator can't do for us. Can make it simpler.